So today we're going to be focusing on factoring monomials, but before we get into actual factoring, we're going to talk about the greatest common factor, which is a topic we've kind of talked about before when it came to the LCM and just finding the GCF of a set of prime numbers. So just as a reminder, what is the greatest common factor? It's just the biggest or the highest factor or number that divides exactly into two or more numbers. So again, what's the biggest number that you can divide into it? So breaking down some numbers and seeing the largest number that goes into them. So let's go ahead and look at our first example. What is the GCF of the numbers 10 and 5? So most of the time you can do these in your head, but just to write it out, I know that 5 divides into both of these, so I can write these two numbers as multiples of 5, where 5 would be my greatest common factor. So that's pretty much the general idea. Just look for that bigger number. Always check the other two numbers that you don't have another number that divides into both of them, because then you have just a common factor and not the greatest. Let's move on to number 2. What is the GCF of 12, 15, and 27? Again, you would say 3 in this case. 3 times 4, put the negative, 3 times 5, and 3 times 9. GCF is 3. Double check the other numbers. Nothing else divides into them, so my GCF is 3. Let's move on to the next problem. What is the GCF of 9, 18, and 27? If you said 9, you are correct. If you said 3, then you would have realized it when you checked what you have left. So we have 9 is a multiple of all 3 numbers. We have 1, 2, 3 left, which do not have another common factor. Therefore, 9 is my GCF. So that's pretty straightforward, but now we're going to get into actual expressions. What is a GCF of an expression? So in this case, it works the same way. We just ask ourselves, what is a GCF of the individual terms? Remember, they're separated by pluses and minuses, but besides that, it works the same way. The GCF here is 4. This is because A can be broken down into a multiple of 4, so my GCF here of this expression is just 4. Same idea. Let's work on number 5. What's the GCF of 5 minus 15x plus 20x squared? You should recognize these as multiples of 5. Just so you can see it here, they all have a multiple of 5, so your GCF is 5. So that's just a basic idea of what the GCF is. Go ahead and try out the next few problems. Go ahead and pause your video and answer these and check your answers after you're done. So now that you're done answering 6 through 11, let's check your answers. So first one, you should have gotten 5. Second one, 7. Next one, 4. Following one, 2. The next one is -9. So if you forgot the negative, you always want to factor negatives if all the terms have a negative. And the last one, what did you get? You should have gotten 1. Reason why is because 7 is prime, so there is no number to break it down besides 1 times 7, which is not a multiple of the others. All right, let's move on. So now that we know what the GCF is, turn to the next page, and we're going to be filling in the information on this section. So factoring is just another way of looking at the distributive property. Write that down. I'm not going to have enough room here. So it's pretty much the distributive property, but you're just kind of going in the reverse order. So in multiplication, we can distribute through a number or variable to all the numbers and variables inside like so. So if I have this problem, I just go ahead and distribute by multiplication, always making sure not to forget to multiply all of them by the number on the outside. So I'm multiplying through, and I get the following expression, 6x squared plus 12x plus 15. But one thing to keep in mind is that if we can go forward, I believe you guys already have the word go forward, right? Then you can also go backwards. So again, if I can multiply through, I can also unmultiply, which is pretty much what factoring is. So in other words, we can go from 6x squared plus 12x plus 15 and work our way backwards back to 3x squared. 3 times 2x squared plus 4x plus 5. And this is what we call factoring, when we work backwards, when we undo multiplication, or if you want to think about it this way, for expressions, when we undo distribution. So we're always going to have this number on the outside, and this number is going to be our GCF. So the number that we unfactor, if you want to think about it that way, it's going to be our GCF. So let's go ahead and move on. So the general process, what you have written out, is you always want to start looking for that GCF, because that's the number, the part that's going to go on the outside of the distribution. And then you want to, once you break down your numbers individually, like I was doing earlier, I'm going to circle the common factors just as I was doing earlier. And then you're going to write your answer out. What goes on the outside here? That's your GCF. And then this stuff right here is just all the stuff that is left over. It's not always going to be 3. It might be 2. It might be 4 terms. It might be 2 terms. I need to make sure to put my plus and minus signs here accordingly, depending on what I have. So just as a general form, this is what it's going to look like. And just this part in green says the GCF goes on the outside, and what's left plus what's left plus what's left, whatever it is, what's left goes on the inside. Whatever is not the GCF, what's left goes back on the inside. And you always want to check your answer by just kind of redistributing in your head just to double check. So let's go ahead and try some of these out. Number 1, so we have 12. We're going to go ahead and factor. You should recognize 4 is the factor of this number. So we're going to go ahead and take care of that. I'm going to break it down. I'm going to write out the number, and I'm going to circle the common term. It really helps to write it down just to get used to it, especially at first. I'm sure some of you guys will be able to eventually do this in your head. Notice as I circle the GCF, which is 4, I'm also circling the times, because that's going to replace the 4 with the parentheses. This is 4 times, so I'm undoing the multiplication. And on the inside, I put what's left, the leftover. So it's going to be the 3x. I bring down my positive sign, and then the 2. So this is what goes on the inside. So GCF on the outside. What's left goes on the inside. You don't have to actually write that part down. So final answer is 4 times quantity 3 plus 2x. All right, let's move on to the next one. There it is, a nicer font. All right, number 2, let's go ahead and look at our expression. We see that 6 is a multiple of both of them. And this one's going to be 6 times 4. I'm going to bring down my x, so I won't forget it, and 6 times 4. I'm sorry, that was a mistake. Let's do it again. It should be just 6 times x. I was thinking ahead. 6 times x and 6 times 4. Going to circle the 6 and the times and replace it for 6 times in parenthesis form. And what's left goes on the inside, noticing that I do have a minus sign this time around. If you want to try ahead and do the rest of them, feel free to do so, or I'll just go ahead and go through each one. Okay, what's the GCF here? 5 times 3. Bring down the x, and this is 5 times 1. Let's not put that plus sign for now. GCF is 5 for both of these, so it's going to be 5 times. So I'm doing the multiplication, and I'm left with 3x, bring down my positive sign, and 1. So this 1 right here is a placeholder because I did take out the entire number, but I need to actually put something there in order to work backwards. So this is a common mistake to forget that 1 and just put 3x plus, or just 3x. But I'm sure you guys won't make that mistake. Let's move on to the next one. All right, here we have another one. This one just is a trinomial. It's got 3 parts, so I got to make sure something that's in common, or the GCF among the 3. 3 is a multiple of all of these. So it's 3 times 2 and 3 times 4. If you want to put the plus signs, that's fine. You don't actually have to put them. So I'm going to put 3 times because I have a 3 times in each one of these. Bring down what's left. So I put x squared minus 2x plus 4. All right, let's move on to the next one. Here's the answer one more time. Here, next one is going to have a GCF. Sorry, it's been a little slow on the iPad. Just give it a second to catch up. There it is. What's the GCF of all 3 of these numbers? And again, realize that all of them have a negative, so it's going to be -7 times 2 here, -7 times 3, and -7 times 10. Let me just put the x squared. So -7 times is my GCF, and I put my parentheses for the times, and what's left goes on the inside. Make sure that you put the correct sign. Notice I'm putting plus signs because I took down or I took out the negative sign. So be very careful because this is a place where it's a potential to make another mistake. That's why we always want to make sure by checking our work. And now it's your turn, so go ahead and do the try these problems. There are 4 of them. So go ahead and try them out. Pause the video and come back when you're ready to check your work. All right, so now that you've done 6 through 9, go ahead and check your answers. You should have gotten 12x plus 2 with that quantity. 2 times the quantity 8a minus 1. GCF was 10 for the next one, so you should have gotten 10 times, give it a second, it's coming, times the quantity 3s squared plus 7s plus 10. And the last one, if you were having trouble with that one, is the GCF was 1 for this one. So that means that you cannot factor if it has a GCF of 1. There's no point. Why write 1 times 4 plus 11? Let me write that down. 4x plus 11, I should say. It's not really factored. It technically is, but it technically isn't. So just future reference, don't bother writing this because just put not factorable. It doesn't really do much to take out the number 1. So let's go ahead and move on. And that's pretty much it for you guys, actually, for the notes. Now it's your task to go ahead and work on the actual practice. And then the next page is more of a word problem. And make sure as you're working on it, you're going to be needing the calculator. If you have any questions, ask after I'm done giving the whole class notes. Good luck.